again, welcome to class. Today we'll be looking at the condition for parallelism and perpendicularity. When do we say that two lines are parallel? When do we say that two lines are perpendicular? These are the two things we're going to be looking at. And we're definitely going to be looking it up with coordinate geometry. I'm talking about line geometry, because of the straight line. And then eventually we are going to get to a better understanding of what I'm trying to drive out. So, perpendicularity or parallelism, and what? Perpendicularity. Do you understand? That's what we're looking at now. Now, first of all, let me look at parallel. When do you say that two lines are parallel? Let's talk about that first. When do we say two lines are parallel? Two lines are said to be parallel, or parallel lines are lines that are equidistant from each other. Any line that is equidistant from each other and that has no propensity or potentials of clashing is called parallel lines. So lines that are moving on straight line with equal distance and they are not shifting their ground, they are called parallel lines. So, like I said in one of those classes initially, that the angles between parallel lines is 0, and that's because they are not intersecting. Until two lines intersect, angles are not formed. So, in other words, these lines are called parallel lines because the distance from here to here is equal to the distance from here to here. So, there's no chance at all that both of those lines are going to clash or meet at any point in time. So, such line is referred to as what? A parallel line. It's called a parallel line. So how be it? Like I said, the angle between parallel lines are what? Is what? 0 degree. How be it? When we bring it to the concept of angle of straight line, we observe that two lines are said to be parallel because this is a straight line. And it has a slope m1. Let's see how the slope m1 and has a slope m2. So two lines are said to be parallel. Two lines, say line n1 and line l2, are said to be parallel if they have equal slope. That is, if the slope of line L1 is equal to the slope of line L2, then we say they are parallel. Two lines are parallel when they have equal slope. Very, very, very informative and we get. But in the other way, or when we say that two lines are perpendicular, yes. Two lines are said to be perpendicular if the angle between them is simply 90 degrees. Yes, when you have a vertical angle clashing with an horizontal angle, they are said to be perpendicular if the angle between them is simply 90 degrees. So what does that mean? If I have a line like this and I have a line like this, they are not perpendicular because the angle between them is not 90. Before I can call a line, because I say a line is perpendicular to another line, then the angle between the two lines must clearly be what? 90 degree. Very, 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 very informative and kept to heart. So this is line N1 and line what? L2. How we this has the slope of M1 and this has the slope of what? M2. Do you understand? So two lines are set to be perpendicular when the product of their slope is equal to -1. That is, when you multiply slope M1, you multiply the slope M2, the product of the slope will give you -1. That is when you say that two lines are perpendicular. Apart from the fact that two lines are perpendicular when the angle between them is 90. And the links between them is so beautiful and something that is not observed, especially when we try to link it up in the aspect of vectors, because it makes much more sense that way. But that is not the talk for today, obviously. So we're going to take an example. Like I said, you know that style. I like it. One example that is very comprehensive, then you can tackle any other example as you want. So imagine that example, let me use the word imagine since I've said it. Imagine you are given the equation of a straight line. The equation of a straight line. Let's say y equals let me say 3/2x minus 1. And I said that solve for the equation parallel to it. Parallel to it. Parallel to it. Giving the coordinates. Giving the what? The coordinates. Let's say you have the coordinates -1 and 2. And solve for the equation perpendicular to it. Perpendicular to it. Now, before I solve this equation, you understand? I need to just keep this once. Let me not rush anything here for you. Before I solve this equation, let me show you what it means when we say two lines are parallel and two lines are perpendicular. Normally, look at this. I can just write an equation. As we give me this equation, 3y equals 3x minus 2. I say I should look for an equation that is parallel to this. I'm just saying y equals 3x plus 5. Y equals 3x minus 1. Y equals 3x minus 100. Y equals 3x minus plus 1 billion. As long as the slope is still 3, 3, 3, 3, 3, 3, then they are parallel. So what's determining here being parallel is the slope. As long as the slope is still 3, 3, 3, 3, 3, I will say the lines are parallel. But what if you ask to write an equation that is perpendicular to this? Then I will simply say y equals minus x over 3 plus 1. Why? The slope here is 3. The slope here is minus 1 over 3. I'm multiplying it now. 3 times 3l1, 3l1. 1 times minus 1 minus 1. Since the product of their slope here is minus 1, then they are perpendicular. Are you getting what I'm saying? Okay, this is what I'm saying. Assuming y is equals to 2 over 3x plus 14. And I'm asked to solve for the equation of a line that is, let's say, perpendicular to this. You understand? I know that this is my slope m1. You get the gist? My m1 is over 3. And I know that when I multiply this, my m1 with m2 must give me minus 1. If I do that, that means my m2 is minus 1 over m. When I divide by minus by m1, then it means minus 1 over 2 over 3 by fraction minus 3 over 2. So I just need to look for an equation where the slope is minus 2 over 2x plus 1. This line is perpendicular to this line without stress. Easy. The moment you can know that, then it's easy for you to navigate your way around parallelism and perpendicularity eventually. So let's try to solve what I'm telling you about, having this knowledge already. So I'm not trying to make up for your classwork or classwork. I'm only trying to complement whatever your teacher has taught you in class, so that it becomes much more easy for you, and so that when you try to read your textbooks, it becomes much more easier and clearer for you to read. Now look at this. We are given an equation of a straight line, say y equals 3 over 2x minus 1. We are asked to solve for an equation of a straight line that is parallel to this. But it has a coordinate of minus 1 and 2. So it has a coordinate of minus 1 and 2. But the slope of this guy, m1, is what? Is 3 over 2. If it is parallel, indeed, if it is parallel to this line, it means that my m2 is also what? Equal it. Yes, 3 over 2. Because two lines are parallel when their slopes are equal. That being said, I'll now say slope is equal to 1 minus y1 over x minus what? x1. So what's my slope? 3 over 2 equals y minus x1 y1 y minus 2 all over x minus 1. And that is equals to what? 3 over 2 y minus 2 over x plus 1. So what do? I cross multiply. When I do that, I will have 3 in brackets x plus 1 equals 2 brackets 1 minus 2. Expand. 3x plus 3 equals to 2 1 minus 4. You get makes sense to me? So for like terms, it becomes, let's rearrange it first of all, 3x plus 3. Then it becomes 2y equals 3x plus 3 plus 4. Then it becomes 2y equals 3x plus 7. Divide both sides by 2. Remember the drill? Then 2 equals to 3x over 2. 7 over 2. Cancel. y equals 3 over 2x plus 7 over 2. What is the slope here? 3 over 2. What is the slope here? 3 over 2. They are parallel eventually. So that's exactly what we're asked to solve for. Then that said, in the same way, we should solve for the equation of a straight line that is perpendicular to the same line. So what do? I know that for perpendicularity, for two lines perpendicular, the product of their slope must be equal to minus 1. Since my m1 is already 3 over 2, are you there? Then it means that my m2 is minus 1 over m1. I divide by minus 1. So my m2 is minus 1 over 3 over 2, which equals to minus 2 over 3. Then I'm now going to go by my formula m equals 1 minus y1 over what to x plus s1, using the same coordinates that I'm giving to us. That being said, it implies that my m is minus 2 over 3 equals to y minus what? Y minus 2 over x minus minus 1, and that is minus 2 over 3 equals to y minus 2 x plus 1. Then I simply cross multiply. Cross multiply, I have minus 2x plus 1 equals 3 bracket y minus 2. When I expand the bracket, I have minus 2 equals 3y minus 6. So rearrange it. So 3y minus 6 equals minus 2x minus 2. Then correct line times 3y equals minus 2x minus 2 plus 6. So 3y equals minus 2x plus 4. Divide both sides by 3. So 3y over 3 equals minus 2x over 3 plus 4 over 3. Cancel. My answer is minus 2x over 3 plus 4 over 3. So what is my slope here? From what we know, my slope is equals to minus 2 over 3. What is my slope here? 3 over 2. When I multiply it over half, just take out minus 1. So that is exactly what we do in getting answers that has to do with perpendicularity and parallelism. So I urge you to go and try much more examples, and I can assure you that it will become much more easier because of this class. Thank you for being a part of the class. Do well to subscribe to this channel and also turn on the notification bell so that you can be updated when a new video is uploaded.